All right. So for quiz number 1, so the question asks, a schematic for a car cruise control is given in figure 1A. So complete the block diagram for this system, identifying each of the components in figure 1B. All right. So for question A, fill in the figure 1B with appropriate components. All right. So we start with probably the easiest one, the car body. So the car body is the plant, okay? So car body is the plant or process. So if you have the right answer, plant or process, then you get 1 mark here. All right, the next one is the control device. So the control device is the components that control the speed. Okay, so you have the input speed. So from this figure, the things that control the speed is basically the throttle pedal. So the throttle pedal is the control device. So you get 1 mark here. And lastly, the actuator is the things that moves or will take action based on the control. So the things that move in this figure is basically the engine. So you get 1 mark for this. Okay, so 3 marks for question A. All right, so for question B, in your opinion, how can we redesign the system to make it a closed loop system? And then name one component to add to the system. Then redraw the block diagram. So this is 7 marks. So first we answer the first part of the question. So how can we redesign the system? So the answer basically add a sensor. So if you have the word add a sensor, then you get 1 mark. So to redesign the system to make it a closed loop, so you need to add a sensor. And then name one component, meaning that name the sensor to add to the system. So you can add any sensor that measure the speed. So you can add tachometer. So if you have the word tachometer, 1 mark. Okay, so tachometer basically measure the speed sensor. So I hope student automotive should know what is tachometer. And for pure mechie, maybe you guys maybe not really ever heard about tachometer, but automotive students should know what is tachometer. And then lastly, redraw the block diagram. So redraw the block diagram to make it a closed loop. So basically, for the redraw the block diagram, you can just add a feedback from this original block diagram. Okay, so before that, you need to have this circle, the summing junction. So this is the desired speed. And then basically you redraw all the blocks from figure B. Okay, so I don't put the names in figure B, but basically you need to put the components in figure B, okay? Okay, so after you have this, then you need to add a feedback loop and your tachometer here. And then this arrow goes back to the summing junction. So if you have a summing junction, you get 1 mark for summing junction, 1 mark for feedback arrow, 1 mark for sensor component here, and 2 marks for the original open loop system. Okay, so you get 5 marks for the block diagram.
Sir,
Yep.
kalau macam tachometer tu, saya tak tulis tachometer tapi saya tulis vehicle speed sensor.
Kalau dalam final, I will accept. But for quiz, tak accept.
Okay.
Sebab dalam final, maybe you guys forgot the name. But dalam quiz, maybe boleh Google kan.
Okay, sir.
So for final, if you write speed sensor, it's still acceptable. Speedometer is correct. It's also the same as tachometer. But for the sake of quiz, you guys can always Google. But if you write only sensor, tak ada markah even for final, okay? So because the question asks you to name one component, because you already answer sensor for the first part of the question. So second part also answer sensor, macam apa ni, ulang benda yang sama, okay? So when asked for name, try to give name of the sensor, okay? All right, so for question C, basically ask you to give the advantages of closed loop system. So if you look at lecture number 1, I already put a table describing the differences between closed loop and open loop. Okay, so if since this question is 6 marks, maybe you can give 3 points. Okay, three advantages of using closed loop system. So the first advantages is basically you can because you have a sensor, then you can measure the output speed and compare the output speed with input speed, so as to measure the differences or measure the error. And this error can be reduced through the control device. So you can write here the output speed is compared with input speed using sensor. So that the error can be measured and reduced by the controller. Okay, so if you have the word compare input output, measure error, if you have this word, any of this word, meaning if you have comparing the output and input, or if you have measure the error differences, then you get 2 marks. Okay. The next point is that because closed loop is how to say, not susceptible to disturbance or external disturbance. So you can say in the present in the presence of external disturbance. Closed loop system will not affected. Ataupun maybe the system is not affected by the disturbance. So if you have this kind of explanation, external disturbance is not cannot affect the system, then you get 2 marks. And then lastly, maybe you can say that the closed loop system does not require any recalibration. But in open loop, you need to recalibrate every time. Okay, every time you need to recalibrate the system so that the speed is within the limit that you want. But for closed loop system, you don't need to calibrate because the speed is always measured by the sensor. So you can say no recalibration needed. And because speed is always measured. Okay, so you get 2 marks. Okay, so if you have any points, any other points, please let me know here because I don't remember the any other points that maybe related to this question. Okay. So basically, you need to answer. Basically, if you have 6 marks, so try to give 3 points. Okay. So most student, maybe you see 6 marks, maybe you think that you need to describe the answer in a very long paragraph, but try to answer by giving in point forms. Okay. So kalau accuracy, so what sort of accuracy are you talking about? So accuracy apa tu?
Doktor.
Mm-mm.
Pasal accuracy tu sebab dia kan minta the advantage of using closed loop. So dia punya accuracy tu they are more accurate than open loop system due to their complex reconstruction.
Okay, tapi kalau accurate, kita kena beritahu lah accurate dari segi apa. Maybe accurate dari segi reducing the error is still the same with the first point. So kena beritahu lah accurate, macam mana accurate apa. Kalau accuracy je macam accuracy macam mana tu? Macam tak sampai gitulah. So kalau kata accuracy in terms of producing the output speed according to desired speed, I think that point is still the same as the first point.
Oh, okay.
So kalau jawapan the sensitivity of system may be made small to make system more stable. Stability pun boleh juga. So tak boleh sebab closed loop has problem with stability compared to open loop kalau dalam table hari tu. Because open loop you don't have any stability problems. Meaning that you don't have any vibration problems in open loop system. But for closed loop, because you have this sensor that measure input and output, then the system tend to have some stability problems. We will look at stability problems later maybe after midterm. So stability problems exist in closed loop system. So stability for closed loop tak boleh jadi small lah. Okay, that's not the advantage. Okay, it's basically disadvantage for closed loop because it has stability problems. Kalau equally accurate and are not disturbed in the presence of non-linearity, tu macam disturbance tadi. Point number 2. Okay, maintain the vehicle speed at constant or reference speed. So that's the first point. Okay, output speed is compared with input speed. So basically, point number 1, you want to maintain the speed. Okay, so that's why you measure the output speed and compare the output speed with input speed to calculate the error. Let's say your output speed is higher than what you want, then the sensor will sense this and measure the differences, and you will know that you need to reduce the speed. So in your car, you have tachometer, right? In the dashboard. So when you press the pedal, you think you are pressing the pedal for 110 km per hour, but the tachometer indicates that your speed is maybe 130. So when you look at the tachometer, you know that the speed is 130. So you angkat sikit kaki, you lift your leg so as to reduce the speed. So that's how control works in your car. The tachometer gives some indication what speed is actually is the output speed for the car is. Okay, so you press, the tachometer will give the reading for the output speed, but you don't know whether you press the speed the pedal within the speed that you want. You think you press below 110, but maybe it's actually more than that. Okay, because the tachometer indicates the actual value of the output speed. Okay, so that's basically try to maintain the speed at constant reference speed. So this is the point number 1. Okay, any other point yang macam logik untuk dapat markah? Okay, so if okay, can determine optimum operating condition. Optimum operating condition tu sama juga macam point number 1. Okay, maksudnya you want your car to have speed at optimum speed that you want. Okay, so you tak nak lah kereta awak tiba-tiba suddenly bila tekan pedal dia gerak tanpa measure, rupa-rupanya dah 200 km per hour. So you don't want that to happen. So that's why you have sensor to measure that and will be indicated by the tachometer dekat dashboard tu. So that is the first point. Okay. The simplicity of the determining an optimum operating condition that allows to reduce the flow rate to the minimum values. Kalau saya tak bagi markah, saya tak tahu apa benda awak cakap. Kalau nak dekat sama jawapan memang tak ada markah. Dah sama adalah markah. Monitor system output and monitor the desired output. So this is basically point number 1, but not complete. The answer is not complete. So you need to answer compare the output and input speed. Okay. Memang tujuan sebenarnya tujuan tachometer tu untuk monitor the system output and input. But the advantages of having tachometer is basically you can compare the two speeds. So as you can reduce or increase the speed according to the error. Okay. So point timer solver ni maybe satu markah je kot. Okay, any more? So kalau tadi kita tengok soalan D. So kalau soalan D, identify and describe one disturbance that may affect the system. Okay, so disturbance is any external things that can cause the speed, the output speed or the actual speed of the car to reduce or to increase. Okay. So there are many examples of disturbance. So the first example, maybe you can say wind. So you have a wind flowing maybe from the front of the car or maybe from the side of the car. This is a disturbance. Okay, disturbance that can reduce the speed of the car. Another example is maybe elevation of road. So let's say suddenly you are moving on a hill, for example, up a hill, then there's an elevation, okay? Sudden elevation occurred. So this is a disturbance because it can reduce the speed of the car. So you need to increase the speed by pushing the pedal. Another example is maybe maybe something that can give a backward force on the car. So backward force on the car may be friction. So friction of the road. Okay, so friction of road. Let's say suddenly you are moving, you drive your car on a sandy terrain, for example. So this could reduce the speed of the car, okay? Because sandy terrain maybe macam menyebabkan kereta tenggelam sikit ke, something like that, okay? Or maybe you drive your car on bawa kereta dekat Kuala Lumpur. Kuala Lumpur kan jalan dia macam bukan tar kan, batu-batu dekat yang dataran Merdeka tu. Okay, so when you drive on that kind of terrain, then it gives some sort of friction, okay, that can change the speed of the car. Okay, so gravitational force selalunya bukan not the disturbance because it's already there kan. So kita semua memang affected by gravitational force. Kalau nak bincang gravitational force ni dia jadi kena masuk physics punya kelas. Tapi gravitational force is not correct, but if you answer maybe when you drive the car down a hill. So when you drive the car down a hill, that's basically the second point here, the elevation. So if you have something like driving the car down a hill, so the car moves faster, so that's acceptable, okay? Changes of slope. So slope and elevation are the same thing, okay? So if you have any of this point, wind, elevation, friction, you get 2 marks. So kalau road condition tu sama macam friction, yes. Okay, so macam waktu hujan, then your road will be covered by water. So you bila drive laju, you punya kereta akan macam let's say you drive at the same speed. So when you drive on a water, then you punya kereta macam akan dia punya speed akan suddenly change lah kan.
So kalau
yep.
Kalau langgar lopak air se macam dalam lubang ke apa?
Sama macam yang Fikri cakap ni. Okay. Bukan Fikri cakap. Bila ada road condition tu lah, maksudnya road condition tu ada air ke, ada lubang ke. But this kind of disturbance basically does not affect the speed much. It is more, it's affecting more towards the kalau ada lubang, kalau langgar lubang, dia kacau speed sikit kot. Boleh lah. Friction of road, condition of road sama je kot. So the question describe how this disturbance describe how this disturbance may affect the system. So kalau wind tadi, the wind will give a force, maybe a backward force or a sideway force, for example, that could reduce the speed of the car. Explain lah macam mana, janganlah explain wind menyebabkan kereta terbang, merepek sangat. Okay, so elevation of the road, because to go up a hill, then the user will have to increase the speed of the car, or to go down a hill, then the user have to brake the car so as to reduce the speed. And friction of the road or condition of the road, the same thing as elevation. When you drive your car through a hole or water or some road that has different condition, then you need to either increase the speed or reduce the speed so as to avoid injury ke, or to because the speed will reduce or increase, so you need to compensate for the loss or increase of the speed. Okay, so if you have some sort of explanation, then you get 2 marks. Okay. Okay, so this is basically how exam question will be. Okay, will look like. Okay, soalan dia macam kena fikir sikit, dia luar pemikiran. Okay, tak luar sangat pun, semuanya berlaku dalam sekeliling kita. Cuma nak kena jawab tu biar logik lah, biar macam meaningful. Okay, so you can tally up your score and put in the Google form, also with the answer script marked by you. Okay, dengan you tanda kertas tu, snap picture and put in the Google form. Okay, so we can start with lecture number 2. So lecture number 2 basically is chapter 2. So chapter 2 we will go into learning how to model dynamic systems. Okay, so there are many kinds of dynamic system, but in this subject we are going to learn dynamic system of translational mechanics, rotational mechanics, and also we are going to look at how to model dynamic system with gears, and also dynamic system of DC motor. Okay, so before you can learn about modeling dynamic system, we need to learn about the most important concept in automatic control, which is the transfer function. So after completing this chapter, the student will be able to perform Laplace transform and inverse Laplace transform. So I think you already learned Laplace transform in ODE. Okay, so kena ingat balik lah. Secondly, to perform partial fraction expansion. So because you have transfer function later, you need to do partial fraction. And then lastly, to convert differential equation into transfer function using Laplace transform. Okay, so why we use Laplace transform? So basically Laplace transform is a technique to solve a differential equation. Okay, so Laplace transform basically you try to convert equation or function from time domain into frequency domain. So your ODE, the dy dt equals something. So you have t here. So this t represent the time domain. So your ODE is in time domain. So you need to use Laplace transform to convert this into frequency domain. Okay. So usually frequency domain we will denote this by using the symbol S. Okay. So you convert time domain to frequency domain S. So later we will see what is this S means, and this S is very important until the end of this lecture, okay? Until the end of this course, because you will analyze the S here later. So why use Laplace transform? Basically, to solve differential equation, it's not easy if you use integration. So when you learn ODE last time, you need to use integration to determine the function of y here. So you need to use method of separation of variables, apa lagi, characteristic equation, Jacobian apa-apa semua tu lah. Okay, untuk determine the function y from the ODE. But if you use Laplace transform, basically it converts the ODE into algebra, meaning that algebra means that the ODE can be transformed into only plus and minus je. From, let's say, dy dt, you convert it into maybe y plus t, something like that. Okay. So it's simpler to solve compared to using integration. Okay. So basically, Laplace transform has this definition. So you don't need to memorize this definition because you are given table later. Final ada ke? Selalunya final tak ada table kot, tak ingat dah, tapi nantilah check balik. Okay, so this is a function of time domain. So you use Laplace transform to convert it into function in frequency domain. So how to convert it? Basically, you use integration of the function time multiply with exponential of negative st. So here we still use integration, but because Laplace transform has been fully studied, not fully, maybe has been studied a lot, so they already have table for Laplace transform. Okay, so you don't need to do the integration manually anymore. Basically you just need to refer to the table to determine what is the function in frequency domain. So when you have Laplace transform, then you can have the inverse. Okay, so you can also convert from frequency domain to the time domain. So to convert it, basically you use this integration method. Okay. Okay, so thanks to this table, because you don't have to do the integration manually anymore. So let's say your time function, this is time function, this is frequency function. So let's say your time function is del t. So del t basically is a function that has this value. Okay, delta t is basically a function that has value 1 when time is 0. Okay, that's delta t. So when you convert delta t to frequency domain, so basically it equals to 1. Okay, in frequency domain it becomes 1. Second function is ut. Okay, ut or step function. So ut basically a function that has value 1 for time bigger than 0. Okay, so for time bigger than 0, the function f equals 1. So this is a function ut or step function. So when you have step function, if you use Laplace transform, then it becomes 1 over s. The next one is when you have step function multiply with time. Okay, t times ut. So if you have tut, it becomes 1 over s squared in frequency domain when you use Laplace transform. So more general, if you multiply with many t, so t to the power of n times u, then in frequency domain, it becomes n factorial divided by s to the power of n plus 1. Okay, next is when your step function is multiplied with exponential of negative at. So when you have an exponential at the beginning, then in frequency domain, it becomes 1 over s plus a. Okay, so you need to take note here, it's s plus a, when here is negative a. So let's say if you have EAT, then it becomes 1 over s minus a. And then the next one is when you have the step function multiply with sine function. So in frequency domain, it becomes omega divided by s squared plus omega squared. And then the next one is multiply with cosine function. Then it becomes s divided by s squared plus omega squared. Okay, so this is the general table for selected function. But there are many more function, but you are usually will be asked these 7 items only. Okay, and the next one is the theorem for Laplace transform. So the first theorem is this is the definition for the Laplace transform. Okay, so basically you use integration. So since you have table, so you don't need to remember the integration. Okay. The second theorem is when you have a linear multiplication on the function. So let's say your function is ut, and then you have a linear multiplication, let's say 2 times ut. So in frequency domain, you just put u times 1 over s. Okay. So ut is 1 over s in frequency, and 2 you just multiply with 2. Okay, so this is linearity theorem. So another theorem number 3, basically, if you have function in the form of addition or subtraction, so in frequency response, you just apply Laplace transform for each of the function. So let's say 2 times ut plus ut tut, for example. So in frequency domain, it becomes 2 over s plus 1 over s squared. Kot, tak ingat dah. Okay, so you can apply Laplace transform separately, okay, for each of the function when you have plus or minus, okay. Okay, here is the time shift theorem. So if you have time shift, let's say t minus 3 ut minus 3. So in frequency, you just multiply with exponential of negative 3s, okay, for this case. And then scaling theorem, if you have the time is scaled with something, so let's say u to t, so in frequency domain, it becomes 1 over 2, 1 over s over 2 coed, okay? But these two usually will not be asked in exam, okay? And then differentiation theorem. So if you have df dt, then in frequency domain, it becomes s times f. Okay, s times f. Okay, so this is the df dt. So f becomes f and multiply with s. And this is the initial condition. So usually initial condition, I will give 0 initial condition. Okay, so when 0 initial condition, you can ignore this, okay? So most of the time is 0 initial condition, okay? So don't worry much about having different initial condition. So if we are going to ask different initial condition, then I will inform you, okay? And if you have d squared f dt squared, so you just multiply with s squared times f. So if you have differentiation of any power, so it becomes s to the power of n multiply with f. Okay, so the remaining three theorem is not important, okay? So what you need to know is that the linearity, the and the differentiation, okay? You need to know these three things only. Okay, this example shows how they calculate the differentiation of A using integral approach, okay? So dy dt equals A. So to get y, basically you integrate A, so you get A times t. But if you use Laplace transform, you can simply convert this dy dt becomes s times ys. So this is differential theorem just now. And A becomes A over S, okay? So why A over S? Because here it's A times ut, okay? But most of the time, we don't write ut here because ut, as I said, is a function of function equals to 1 when t bigger than 0. So here we always assume time is bigger than 0. And here A meaning that A times 1. So when time bigger than 0 and this is equals 1, meaning that this is the function ut. But because time is bigger than 0, we always assume, and this is equals 1, so we tend to not write ut here, okay? Because it's equals to 1, okay? So tak payah tulis balik lah sebab dia 1, okay? So here it becomes A over S. So rearrange, you get ys equals A over S squared. Okay, so you need to perform inverse Laplace transform to get yt, because now it's ys in frequency domain. So you need to get in time domain, okay? So to get in time domain, you need to use inverse Laplace transform. So inverse Laplace transform ys, you get yt. So inverse Laplace transform of A over S squared, first you need to factorize A because of linearity theorem. So 1 over S squared becomes T times ut. So we know that ut equals 1. So you just write a times t, okay? So it's the same answer with the first integral approach. But here it seems that you take more steps to calculate y equals at. But what happens if you have a more complex function? Then you will have more time to spend if you calculate using integral approach, okay? But if you have a very simple function, then using integral approach is a lot faster. So here is another example. If you have ft equals a times exponential of negative at times ut. So what is the Laplace transform? So if you use integral approach, then macam pening sikit. Okay. But if you use a Laplace transform, you can simply refer to the table. So if you look at item number 5, then e exponential of minus at ut becomes 1 over s plus a. And using linearity theorem, so if you have a multiplied by e minus at ut, then you just put a at the end, okay? Basically, you just put a here times 1 over s plus a. So you need to Laplace transform this section first, and then multiply with a. Okay, so it's a lot faster than using integral approach. But you need to refer to table, okay? Okay, so some exercise. Find the Laplace transform of the function ft equals 6e exponential to the power of minus 5t plus e power of 3t plus 5t cubed minus 9. So here you need to perform Laplace transform for each of these functions separately because you have algebra here, okay? Plus and minus. Okay, so you can perform Laplace transform individually and then add up later. Okay, so the first part is basically 1 over s plus a. And the second part here is the n factorial divided by s power of n plus 1. And the last one is 9 ut, okay? So since ut is equals to 1 for time bigger than 0, so we ignore, okay? We tend to not write this, okay? So from the table, the first part here becomes 6 times 1 over s minus 5, okay? Or s plus 5. The second part here, it becomes 1 over s minus 3. Okay, so you have minus here, then it becomes plus. So if you have plus here, then it becomes minus, okay? And the third one is 3 factorial divided by s n equals 3. So 3 plus 1 times 5 here. And lastly, it becomes 9 times 1 over s. So you simplify, you get this answer. Okay, so for second exercise, find the Laplace transform of gt equals 4 cosine 40 minus 9 sine 40 and plus 2 cosine 10t. So this is the cosine formula from the table. So here you need to make sure what is the value for omega. So the omega here is 4 and 10. So you need to make sure the right omega and substitute the omega into the equation from the table. So simply substitute and using linearity theorem, so you end up with this answer. Okay, so that's the first outcome. So you have learned about Laplace transform and inverse Laplace transform. So now we are going to look at partial fraction, how partial fraction plays a role in determining the transfer function using Laplace transform. So partial fraction basically is a mathematical technique to help you use inverse Laplace transform. So let's say you have this frequency function. So you have 2 divided by s plus 1 times s plus 2. So in the table, you don't have this kind of function, okay? So your function is usually s plus a or 1 over s n plus 1. So you don't have 2 times of s plus a on the denominator. So you need to split this function using partial fraction to get the equation in this form, okay? So when you split this into this, then your fraction becomes partial fraction and can be applied Laplace transform for each of this function, okay? Because it's already in algebraic form or in linear form. So here, if you apply inverse Laplace transform, you will get k1 e minus t plus k2 e minus 2t. So here the problem is you need to determine what is k2 and what is k1 using partial fraction expansion. So there are 3 cases for partial fraction, but usually we will ask you the first case only when you have real number and distinct denominator. Okay, so this is an example of real number and distinct denominator, okay? And for the remaining 2 cases, maybe you will use this in your project later. So you need to use MATLAB. Okay, you can calculate this using MATLAB or using Symbol Lab, okay? So let's look at an example how to use partial fraction for the first case, okay? So when the case for real number and distinct roots, so let's say you have this function in frequency domain. So s plus 2 divided by s times s plus 5. So this is real root in the denominator, real number, and distinct. Distinct means different, okay? So this is the root here is 0 and the root here is minus 5. So it's real number and distinct. So you can split this into 2 fraction. So the first fraction is a over s plus the second one is b over s plus 5. So now you need to determine what is a, what is b, okay? Okay, so this is the method used by this slide, okay? So what this actually tell us is that when s equals 0, then you can substitute s equals 0 on this function. So you get 2 divided by 5, okay? So that's the value for a. The second one is when s equals minus 5, then you substitute minus 5 here and minus 5 here. So you get 3 divided by 5. So this is another method, but maybe some of you are confused, okay, with this method. So you can use the method that you familiar, okay? So the method that I familiar is that first I need to simplify this into one fraction first. So it becomes a times s plus 5 plus b times s divided by s times s plus 5. And then I compare this fraction with the previous fraction, okay? So I get a times s plus 5 plus bs equals s plus 2. And then I assume if s equals 0, then you get a times 5 equals 2. So a equals 2 over 5. And then I assume s equals minus 5. So I get minus 5 times b equals minus 3. So I got b equals 3 over 5. Okay, so basically you need to look at this root. So the root here is s equals 0. So you choose s equals 0 and substitute back in the original equation here. So when s equals 0, then you get 5 times a. S equals 0, so you get 0 here. Equals 0 plus 2, so you get 2. Simplify, you get a equals 2 over 5. And then you need to look at the second root. Here is s equals minus 5. Substitute in the original equation. So a times minus 5 plus 5 is 0. So it's 0 here. Here is minus 5 times b. So you get minus 5b equals minus 5 plus 2. So you get minus 3. Simplify, you get b equals 3 over 5. So when you get the value of a and b, so you need to resubstitute into the into this equation. And then apply inverse Laplace transform. So you get 2 over 5 over s, you get 2 over 5. 3 over 5 over s plus 5, you get 3 over 5 times e power of minus 5t. Okay. So you need to use inverse Laplace transform here, okay, to get the time domain, the y in time domain from y in frequency domain, okay. Okay, so we look at one exercise. So determine the time response yt from the frequency response ys below. Okay, so here I want you to take note when the question tells you time response, meaning that the function in time. Okay. When the question says frequency response, meaning that the function is in s, okay, in frequency. So sometimes the question asks you determine the time response of the following frequency response. So it doesn't say find yt, it just says find the time response. So maybe you are confused what is time response. So time response, basically you need to perform inverse Laplace transform of ys to get yt. So here ys is in one fraction. So you need to split them using partial fraction. So the first step is you need to factorize the denominator. So here you get s minus 5 times s plus 3. Okay, so you already split them. You already factorized the denominator. So from here you can split them into two fractions. Okay, so you can write a over s minus 5 plus b over s plus 3. Further simplify, you get a times s plus 3 plus b times s minus 5 over s minus 5 times s plus 3. Okay, compare this with original equation. So you get a times s plus 3 plus b times s minus 5 equals 17s minus 53. So we look at the root of this equation. So the first root is minus 3. So take s equals minus 3. So you get minus 8b equals minus 51 minus 53. So you get B equals minus 104 over 8 minus 1, 3, 13. Kod, okay? Check balik, okay? Saya tak ada calculator. Okay, the next root is when S equals 5. So S equals 5, you get 8A equals 5, 5, 33, 85. So 85 minus 53. So you get A equals 4. 32 divided by 8. Okay, so substitute back in the original equation. So you get ys equals 4 over s minus 5 minus 13 over s plus 3. So perform inverse Laplace transform. You get yt equals 4 times e 5t minus 13 times e minus 3t. Senang je, okay? Tak payah fikir panjang. Tapi kena biasa buat lah, okay? Kalau tak biasa buat, masa nak exam baru buat, mendapat lah fail. Okay, so this is for partial fraction expansion. Okay, so now we are going to look at the definition of transfer function. What is transfer function? So transfer function is one of the most important things that you need to know in automatic control, because you will be given a lot of transfer function after this, okay? And transfer function is basically a frequency domain mathematical model that separates the input from the output. So transfer function is a frequency domain, okay? A frequency domain maths model that separates input from output, okay? So let's say here you have the input. Here is input C. C is input, and R is C is the output, and R is the input. So here, in your control system, you can describe the control the system by using the output and input using differential equation. Okay. So in your block diagram just now, you have output and input. So this input and output can be written in differential equation using this. Okay, using this C as the output, R as the input. Okay, so you can rearrange this to get the transfer function. So how to get this transfer function? So first, what you need to do is you need to convert this time response into frequency response. So you know that dct dt in frequency response, you get S times C times S, okay? S CS, okay? S times CS, okay? So this is from table. So dc dt becomes SCS. So 2CT in frequency response become 2 times CS. And RT in frequency response, you get RS. And then you rearrange this so as to get output over input, okay? So you rearrange to get output over input, so you get 1 over S plus 2. So this thing here is your transfer function. Okay, so transfer function basically is a mathematical model that writes the output over input, okay? But in frequency domain. Okay, so transfer function is in frequency domain, okay? But it basically writes the relationship between output and input. And then from here, you can find the time response of the transfer function. Okay, so this is the transfer function ys. So you can let cs over rs equals ys. Then you can convert this into frequency time domain, okay, or time response. So here you get in time response, you get e exponential e to the power of -2 times t. Okay, so you need to use inverse Laplace transform to get ys in terms of yt. Okay, let's look at an example how to convert differential equation to a transfer function. So let's say you are given this differential equation. Okay, so if you want to do this manually using integration, it will be very difficult. Okay, so we can use Laplace transform to convert this in frequency response. Okay, so the first thing you need to do is here it's d3 ct dt cube dt cube. Then in frequency response it becomes s cube times cs. Okay, same goes with this. So this becomes 3 times s squared cs. And this one becomes 7 times s cs. And this becomes 5 times cs. Equals, this one becomes s squared rs. This becomes 4s times rs. And this becomes 3rs. And then you factorize c and r. Okay, factorize out. So you get cs times s cubed plus 3s squared plus 7s plus 5 equals rs times s squared plus 4s plus 3. Rearrange them to get in transfer function. So transfer function always output over input. So in this case, we say that cs is the output, rs is the input. But maybe in exam, they will tell you, okay, which one is output, which one is the input. So here you rearrange them in terms of transfer function. Okay. Okay, so you get this transfer function. Then after this, you can use partial fraction expansion, and then use inverse Laplace transform to get yt. Okay, the time response. Okay. Okay, sometimes you can convert from transfer function to differential equation. So let's say you are given a transfer function here, so you can convert them back to its original differential equation. So rearrange them. So this multiply with cs and this multiply with this. So you get this equation. Expand, and then cs s squared becomes d squared dt squared. Okay, and this one becomes dc dt. This becomes 2 times c. This becomes dr dt, and this becomes r. Okay, so you get in terms of differential equation from transfer function. Oh my god, bila nak habis? Okay, so dah habis. Yay. Mana quiz? Cepat. Okay, so this is a take-home exercise. If you have time, you can do this exercise. If we have time, we can discuss this maybe before midterm ke, before final ke, masa time-time korang gelabah dah. Okay, we can discuss this if you remember. Okay, so this is the quiz number 2. It's still 2%. So siapa yang datang kelas minggu pertama dapatlah 2%. So due date for this is Friday 12 a.m. at 12 bukan. So Saturday 12 a.m. okay. Or Friday midnight. Okay, so the question asks, consider a system described by differential equations. Okay, this is the differential equation. Find the system response, yt, to an input rt e minus t ut. So the first step you need to do is you use Laplace transform on this equation first. And then you Laplace transform this thing. And then when you get Laplace transform of this equation, you will get ys over rs. Sabarlah. Okay, so you get ys over rs equals something. Then you get rs from here. Okay, so here you get rs. And then after that, you determine ys equals something times rs. Okay. And then from here, you will use a partial fraction and inverse Laplace transform to get yt. Okay. So that's the step. Okay. So you need to convert this using Laplace transform. Then convert rt using Laplace transform to get rs. From the differential equation, arrange so that you get ys over rs. And then substitute rs from this, you get ys. And then perform partial fraction expansion and inverse Laplace transform to get yt. Okay. So this is a past year question midterm. So if you can find the answer, lagi senang. Okay, mana tahu keluar lagi. Okay, so that's all for today's class. If you have any question, you can ask me now or later. Okay, so make sure you submit before 12 a.m. Saturday. Okay, that's all. Bye-bye.